Alright, welcome to the last video dealing with functions, and of course my friend here is still with me. Yeah, there he is. I knew he was going to be here. We're going to finish it up. Basically today we're going to be solving a system of equations. There's different ways that we can do it. We can do it graphically speaking, we can do it numerically, all sorts of different ways. Should be a relatively short video because most of this stuff should be review. I really think you've seen this stuff before, so shouldn't be too bad today. Alright, so let's go ahead and cut to the dot cam and let's get started.
So in the last video I gave you a system of equations, which is about two equations, and I gave you an ordered pair, and I asked you if that ordered pair was a solution to that system. And you basically just plugged in the values and saw if the equations were equal like they were supposed to. We did that. So what happens if you don't have the ordered pair and your job is to find it? So how do you do that? Well, there's a couple different ways. The first way is, I don't know why, I just kind of find it fun. It's not the always the easiest way, but to me it's kind of the fun way. It's solving by graphing. And simply put, we simply graph each equation and see where they cross. We're seeing where the intersection lies. So let's go ahead and look at the problem. So this one, I'm asking you to solve the following system by graphing. I want you to find out if y equals x minus 7 and y equals negative x plus 3. And you're going to solve for it and see if they cross. Alright? Well, basically all you got to do is graph the first equation. It says negative 7. We know that the negative 7 is going to be our slope, our y-intercept, and we're going to plot that. So we have negative 7 right there. Okay, cool. Now what we've got to do is find our slope. Well, remember, what's really in front of this x? It's a 1. So our slope is 1, meaning that we rise up 1 and go to the right 1. And so that's what we do. Up 1 over 1. Up 1 over 1. And we can continue to do that, but all we need is 2 points. So we draw a line. Now for this next one we're going to do the same thing. We're going to plot y equals negative x plus 3. So we go to the y-intercept, which is 3, and you can hear my little boy screaming in the background. I love these home videos. Alright. I may need to pause the video. Nope. I think we're okay. Anyway, so we have plus 3, and then we're going to go down 1 over 1 because this is a negative 1. So it's going to be down 1 to the right 1. And now that we do that, we draw our line again. And again, this is probably not the best of things. Here we go. I think that's pretty accurate right there. So let's go with that. Alright, now that we've graphed it, we're going to see where it meets. Well, they meet right here in the middle. Well, where's that at? Well, this is going to be 5, this is negative 2, so they actually cross at the ordered pair 5 and negative 2. So, what is our answer? The answer to this problem is 5 and negative 2. That's it. So when we go to solve by graphing, we simply graph the line and see where they cross. And nothing all that hard.
But what if I graph these two lines and I got two parallel lines, just like you see right here? Well, if I get two parallel lines, Mr. Hand, help me out, we get no solution. Now, what happens if I graph two lines and they actually make the same line? Wow! Well, in this one, we have infinite solution. So, in this one, I wish the baby would be quiet. I'm trying to record a video. So, when they are parallel, there's no solution because they don't cross. And if they are the same line, it's infinite to infinity and beyond. Well, now that we got the baby quiet, let's continue.
Alright, so the next thing is what we call solve by substitution, And really, here's the definition. Solve one equation for one of the unknowns and substitute it into the other equation. That sounds complicated, but quite frankly, this is actually my preferred method of doing it. Or I would say probably my second preferred method outside of graphing. Like I said, graphing is just fun, but this is more direct. So let's actually talk about what we're going to do. So let's go ahead to the problem. So we have x minus y equals 8 and 5x plus 9y equals negative 86. So what we want to do is basically solve for one of them. So we want to solve for a variable. The easiest one to solve for is this guy, x, and we're going to simply solve for x. In doing so, we find out that x is simply 8 plus y. Alright, now that we know that, we can actually plug this in to this equation. So wherever we see an x in the next equation, we put in 8 plus y. So let's do that. We have 5, 8 plus y plus 9y equals negative 86. We're going to keep on working this out. This is going to give us 40 plus 5y plus 9y equals negative 86. We're going to add our common variables and everything like that, and we're going to subtract on both sides, so we're just going to go on straight to it. We're going to get 14y is equal to negative 126. And now we simply divide by 14 on both sides. And when we do, we get negative 126 divided by 14, and we get that y is equal to negative 9. Well, this means that we only know part of the problem. We don't know the entire problem. So we're actually going to plug in negative 9 back into one of these original equations. So I'm going to plug it back into this one. So I'm going to say x minus negative 9 is equal to 8. Well, I know that this is going to be x plus 9 is equal to 8. And so now we just simply subtract, and I can find out that x is equal to negative 1. So as of right now, my solution set for this problem is going to be the negative 1 because of x equals to negative 1 and negative 9 because y equals negative 9. This is my answer so far. However, I need to prove this. I need to plug both of these numbers back into both of the original equations. So let's do the first one. That says negative 1 minus negative 9. Well, when I do that, that's going to give me positive 8. So when I plug this, it does check out for the original equation there. Let's try it with the other equation. And I'm going to write this one out. 5 times negative 1 plus 9 times negative 9 equals negative 86. Well, this is going to give me negative 5 minus 81 equals negative 86. And the negative 86 is equal to negative 86. So, did this check out? Yes. So both equations checked with my solution. So I know that my answer is definitely, for this particular system, negative 1 and negative 9. Let's try the next problem. So for this problem, we're going to do the same thing. We're going to solve for a variable. And what I'm going to do is I'm just going to solve for x this time because I just want to get rid of the y on one side. Y just because I can. Does it really matter which one I just solve for? No. I could solve for x, I could solve for y, or I could even use this other equation and solve for the x and y there. It really doesn't matter. You just do whatever you want to. But I'm going to do this way. So I know that I get 2x is equal to 1 plus 9y. I'm going to divide by 2 on both sides, and I have x is equal to 1 plus 9y all divided by 2. Now I can rewrite this and simply say that x is equal to 1/2 plus 9/2 y. Now this looks hard, but hopefully when we go to plug this back into our other equation, these fractions are going to go away and make our life a little bit easier. So let's go ahead and do that. Everywhere we see x in this second equation, we're going to plug in this expression, 1/2 plus 9/2 y. So we have negative 18 times 1/2 plus 9/2 y plus 81y equals negative 8. All right, well, negative 18 times 1/2 is going to give me negative 9. Negative 18 times 9/2 is going to give me negative 81y. So that gives me negative 81y plus 81y equals negative 8. Well, what happens here? This negative 81y and this positive 81y cancel out, and I get negative 8 equals, negative 9 equals negative 8. Wait a minute, something's not right. I just got that these two, this is not possible. Negative 9 does not equal negative 8. So let's check our math. I'm going to say I did. Blah, 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 blah. I checked my math, okay? Because that's what I'm supposed to do. And I get the exact same thing again. What is this telling me? When I get a solution like this, where one side of my equation does not equal to the other side of the equation, there is no solution for this system. Alright, so like in the first one, I actually found a solution. I got negative 1 and negative 9. However, in this one, I can't do anything. I get something equals something that, and they don't really equal. So that makes no sense. Therefore, this is no solution.
But what if we have something that says 1 equals 1 or 2 equals 2 or anything like that? Well, where these things didn't equal and these do, this would mean that my solution set is infinite. Infinity. Infinity. I like that word. Bye.
Alright, another way that we can solve a system of equation is by adding or subtracting the actual equations. Otherwise, we also know this as what's called elimination. Personally, I know how to do this. This is not really one of my favorites. I don't know why. It's interesting. Some people like to graph. Some people like substitution. A lot of people like elimination. It's just your own personal choice. The biggest thing is you need to know how to do all of it. Okay? Alright, so here's some basic rules for it. Basically, one, we need to write the equation in this form. So before we do anything, we need to always make sure our equation is in this form: ax plus by equals c. The next thing that we need to do is, if necessary, we are going to multiply all terms of each equation by a constant to make one unknown numerically. Okay, notice that I said numerically. That's a key word here, and I'll explain that a little bit later. The same in both equations. 3. If the numerically equal coefficients are different, add the equations. If they are the same, then subtract. Then after that, we simply solve. 5. Whatever value we got from step 4, we place back into the original equation and solve again. That will give us a new term or a new value, and therefore we need to check both values by checking both original equations. All right, that's a lot of rules. So pause, make sure you've got these written down, and then we'll go on to our question. All right, so in this system, we have x minus 3y equals 6 and 2x plus 3y equals 3. Before we do anything, you need to kind of start paying attention to each of the coefficients in front of each variable. All right, so this one right here has basically a coefficient of 1, where this one has 2. This one has a coefficient of 3, and this one has a negative 3, and this one has a coefficient of positive 3. Now this is where I told you that you need to make sure that they are numerically the same. Look at this. This is a 3. Well, this is a 3. That's telling us that these two numbers, even though this is a negative and this is technically a positive, they're numerically the same. They're not actually the same, they're just numerically the same. It's just the same number, even though we're not the same sign. So in this particular case, now that we know that these are already numerically the same, we can do something. So let's go ahead and put this on top of each other. So we're going to say x minus 3y equals 6, and then we're going to take this second equation and put just below it in the exact same position. X's are under x's and the y's are under y's, and whatever this is, or which it would be, I guess you could call it a constant for our intents and purposes, will be under constant. All right, now excuse me, according to our rule that if the numerically coefficients are different, we're going to add these. Since this right here is a negative 3 and a positive 3, we're actually just going to simply add these equations. What do I mean by adding? Well, simply, I mean add. You're going to literally add up. X plus 2x, this is going to give me 3x. Negative 3y plus 3y gives me 0. And 6 plus 3 gives me 9. So I have just made myself a very simple equation. 3x equals 9. And now I can solve for x by dividing. And we find out that x is equal to 3. Now, knowing this, we can go on to step 5. Place the value that we just found back into an original equation and solve. So let's use this one right here, x minus 3y. So that's what we're going to do. And I'm running out of room here, so I'm going to have to write up top. So we're going to say 3, I'll make this right here, 3 minus 3 times y equals 6. That's going to give me negative 3y is equal to 3. And that's going to give me y is equal to negative 1. Now that I know this, it's telling me that my x is going to be 3 and my y is going to be negative 1. So my ordered pair, or my solution, should be 3 and negative 1. However, we can't just rely on this. We have to do the last rule by putting this back into both our original equations. So let's do that. We have 3 minus 3 times y equals 6. That's negative 1, excuse me, negative 1. All right, 3 minus 3 times negative 1 equals 6. When we work this out, that's going to give me 3 minus a negative 3 equals 6. And does 3 minus negative 3 equal 6? Yes, it does. So this checks out. So this equation is good. So now let's try the next equation. 2 times 3 plus 3 times, man, my children are wild tonight, times negative 1 equals 3. Well, 2 times 3 is 6 plus, this is going to give me negative 3 equals 3. Well, does 6 plus a negative 3 equal 3? Yes, it does. So what does this tell us? It tells us that our solution that we came up with, 3 and negative 1, is correct. Now, let's look at this one. We're going to do the same process and solve by elimination, but let's kind of look at it. We have 0.7a plus 0.4b equals 180. And a plus b equals 300. All right. Well, I've got a little bit of an issue here. When we look at them, the coefficients on each variable are really, really weird. So we've got to find a way to make them the same. How can we get rid, what can we do, what can we get rid of to make our life easier? Well, there's several different ways of doing this. Personally, I like to get rid of the decimals first. So let's just get rid of the decimals first, and then we'll worry about this a plus b later. So I have a 0.7, a 0.4. How can I get rid of these? What can I do to change these from a decimal to a whole number? Well, this is what I know. If I take this 0.7, this 0.7, and I multiply it by 10, that's going to give me the whole number 7. So, and it's the same thing with this 0.4. Multiply it by 10, I'll get a whole number 4. So what I'm actually going to do before I do anything else is I'm going to multiply this entire equation by 10 on both sides. And what happens is 10 times 0.7 gives me 7a. Then I'm going to get plus 4b equals 1,800. Now we got something that seems a little bit more easier to work with because it's nice whole numbers. Now let's look at this next number. We have a and b. Again, we don't have any coefficients that are numerically the same as our previous equation. So what can we do? Well, let's decide which would you rather want to get rid of. Would you like to get rid of the a first or the b first? It really doesn't matter. I'm going to get rid of the a. So in order to do that, I need to make my coefficient here the same as here. So what am I going to do? I'm going to multiply everything by 7. And that's going to give me 7a plus 7b is equal to 2100. Now, let's look at my equations. Are the equations the same? Yes, they are. Though they look different, they're still the same. What else can I do? Well, now that I know that my coefficients on my a variables are the same, I can now get rid of them. So let's do it. I have 7a plus 4b equals 1800. And I have 7a plus 7b is equal to 2100. Well, according to my rules, if the coefficients that are numerically the same and they're the same sign, I'm simply going to subtract. And when I do, I'm going to get negative 3b is equal to negative 300. I'm going to solve for b, and we find out that b is 100. So what do I do now? Well, I'm actually going to take this b and plug it back into one of the original equations. I'm going to use this one, a plus b. So I know that a plus 100 is equal to 300. When I solve all this out, I find out that a is equal to 200. So this is what I know. I know that a is 200. A is 200, so we're just going to say that a is 200 and that b is 100. So here is my ordered pair where a and b. Okay, but we need to find out if this is right. Well, let's plug this back in. A plus b equals 300. Well, do we know that a plus b is 300? Yes, 200 plus 100 is 300. So we know that this equation checks out. Now we need to check out the equation that's a decimal. So I'm going to plug everything in again. 0.7 times 200 plus 0.4, and I'm running out of room, 0.4 times 100 is equal to 180. Okay, so now let's work this out. I don't feel like doing this on my head, so we're going to use our handy dandy calculator again. So I'm going to say 0.7 times 200, and I get 140. Then I'm going to go 0.4 times 100, and I get plus 40 equals 180. Does 140 plus 140 equal 180? Yes, it does. What does that mean? It means that not only was the a plus b equation correct according to my numbers, but so was my other. And since both of those equations match this ordered pair that I gave you, it means that my answer to this solution set is definitely 200, 100. No matter what you try to do or try to solve a system of equations, one of the best things for you to do is try to make the coefficients always easier to work with. Just like the question I just gave you before, if you have decimals, get rid of the decimals as quickly, as best as you possibly can. And if you have high numbers, like in this problem, let's see if we can make them smaller. So in this particular case, I have 40s minus 30t equals 70. Well, what can I do to make this really nice and easy? I can actually basically divide everything by 10, or technically factor out by 10, however you want to talk about it, and we can say that this is another way of writing this equation is 4s minus 3t equals 7. Well, let's look at the next one. We can do the same thing, and we can say that 2s minus 4t is equal to 9, negative 9. Now, yes, I still have to solve this equation. I'm not quite done, but I'm not going to do that with you right now. I think you get the point. And here's my son again. Hey, David. Say hi, guys.
Hi, guys.
All right. So I'm not going to do this with you, but I wanted you to see, try to make life easier on yourself. All right. Let's try one more thing. All right. Last thing we want to show you, or tell you basically, is this. It doesn't really matter what method you choose to solve a system of equations. You can do it by graphing, you can do it by substitution, you can do it by elimination. There's actually several different ways, even beyond that, that I'm not going to cover with you, but I want you to know that you can solve it so many different ways. Quite frankly, I don't care how you solve it, because it doesn't matter as long as you're getting it. Now, the biggest thing I do want you to be able to do is to do any of them at the drop of a hat, so to speak, because sometimes graphing is not always the easiest way. It might be better to use substitution. Then there's other times substitution is and it might be easier to use elimination. So you've got to be able to flip-flop between the different ways, okay? And you have to use your own judgment. It's just that simple. But find the method that you find best and use it, but be able to use those others when the need arises. All right, so I'm leaving you with this right here. Basically giving you a system of equations. Your job is to solve it. Give me the answer, and by the day these notes are due, and I will give you 2 points on your next test.
That's the end of the module 3, so which is a good thing, because hopefully somebody will not be back.
Who?
It takes a lot of video editing to do this.
Are you talking about me?
No, I'm not talking about you.
I'm a liar. You're a liar.
You be quiet. Go
Liar.
away. Anyway, I hope you enjoyed these videos. I will see you next time, and good luck on your test. Bye.